Hello everyone. So as during the class, we just able to show all the steps for up to this page, page number 12. Now there is only one portion left, so I'm thinking to record it and then you can watch that during your free time. And if you're not able to understand, then next class after my class or my office hour you can ask. So here we have we need to know that frames that are free side array. So what is that? Let's suppose we have the frame like this. You saw it before. And now we are not only applying a vertical force, we are also going to apply horizontal force. So due to the horizontal force, there will be that horizontal movement for the frame. So that one we are saying that there is a sideway horizontal movement of the frame due to the lateral force, lateral load, or the you can say that one is the horizontal force. And that horizontal force we saw that things from our first class, first lecture, that one wind or seismic load. Okay, so what if we have that horizontal or lateral force, then we need to consider that things for computing the slope deflection method for uh, the structure for the frame right now. And now that psi, we are saying initial the previous example, we said that their psi a b, that term was 0, but here it will not be 0 anymore. So what will be the psi? Psi will be, can I write something? Let me edit. Okay. And draw something. No. Yeah, I can draw something. So that psi will be the, oh, wait. Okay. So that psi will be in this one. Is there any pointer or something? Annotation. Okay. So that psi will be how much it deflect divided by the, here we are saying the height or distance of that bar. Okay. Now the thing we did before that we need to separate the frame structure, otherwise we are not able to solve it. And then what we need to do, we need to identify um, that that thing is, oh my god, cross. So here we need to identify that what is unknown here. Okay, so uh, can I delete that stuff? No. Yes. Annotation, erase annotation. I need to erase it. Here, and then we separate the structure. I have A, B, B, C, then B, C, C, D bar. We just separate it and then just draw the moment. And now theta B, here what is the unknown? Theta B and theta C, the rotation at theta B and theta C. So that unknown rotation we need to compute. And also here we have the psi, the chord rotation due to the lateral force. That one we're saying that lateral side sway. So that things we need to consider. Then you can just take a moment, equilibrium at point B and C. Then after that, here horizontal force, the way we are solving few minutes ago for another example. So here summation of fx, then that one considered 0. You can take a moment at a, then write the equation. Means it's just showing that if we have lateral force, how to solve it step by step. So this is not like you have to memorize any equation. You just you already know that if we draw the free body diagram, then you can just minimize that. You can just take a moment at A, then after that uh, write the equation, solve it, and then take a moment at D, write a equation. If you are able to solve it, then solve it or go for the another one. Then how to get the shear force for each bar? Look at this one. Just remember that a few minutes ago I was saying for the computing the shear force, summation of the moment divided by, I was saying that length of the bar. They are saying that one each. It doesn't matter the length of that specific bar. Then in that way you can compute their shear force. And here just wrote another equation for this one, total, and that's it. So here we just substitute V1 and V2 here and write the equation. So let's go to the example. So here what happened, that it's saying that we need to analyze the frame using the slope deflection method, and E is constant. Here moment of inertia for 2 bar, AB and BC and CD 3 bar is different. So you need to, right now it's not the same, and you need to consider that one. So first thing first, we have general slope deflection equation. Just write that one. Now, as there is no load applied, so there is all fixed end moments. Remember, I was saying that FEM was 0. So again, I'm saying that if there is no load is applied, we don't need to use fixed end moment diagram. So that term, this term is going to be 0. So here I just wrote that things, and then here, as I have theta at point A, it's a fixed support, so theta A equal to 0. For this one, D point, rotation, theta D equal to 0. So what is unknown? That theta B, theta C, unknown. And also displacement, that one is unknown, because I said they said that here 6 keep load applied laterally. So you need to compute that things as well. Okay, so we can write the equation that what is the psi for AB bar? Delta divided by the length or the height. And now it's height because it's for the vertical bar. So it's a, like you can say it's a column. So here 12 feet, write that one. For CD bar is psi CD equal to delta divided by height 18 feet, write that things. And then here if you want, you can just write that two equation in that way, or you can use in a different format. So here what it is did, that just delta equal to psi 12 psi AB, delta equal to psi CD, then just do the simple math and then you get that equation, just to minimize the structure. And now what we have to do, we need to use, look at this one, that we have 2 EI by L. So that things we are saying that is because right now for AB, BC and CD bar, I is different. So that's why we are going to use different notation. That one we are saying that relative stiffness, K AB for AB bar, EIAB divided by LAB. Just write those things. Okay. For BC bar, again write that things because I is different. For CD bar, moment of inertia I is different. So just write 3 equations. And look at this one, that all the cases for KAB, KBC, and KCD, there is a common term is 20E. So we can just simplify that equation again, say that 20E equal to K. It doesn't matter, you can use this thing we have, but there is nothing wrong if you want to just simplify your equation. So just simplify the equation same way they did shows in the book. So KAB equal to K, then KBC equal to 2K, KCD equal to K. Okay, now we are going to write the moment equation for AB part. We are going to use the general equation, this one. Now we have AB, so it will be theta AB, 2AB, theta B, 3 psi AB. This one is 0 because there is no external load. Okay, so write that thing. And now just substitute all the value. We know that theta A equal to 0, so this term is going to 0, only theta B and 3 psi AB. And we already know KAB equal to this term, so we just substitute that value, then we get one equation. And we also know psi AB equal to 1.5 psi CD. Substitute that value, write the equation. You can ask why we did that. Well, the reason we did that way because we just want to solve that things. It will be easier for us to solve the equation when we are going to write the another equation, moment equation for the part. Now end moment for MBA moment at form. We start from BA, so it will be 2 theta B, theta A, and 3 psi AB. There is no fixed end moment that term, so it's 0. Again, theta A equal to 0, so just cut that things. Again, we have this, simplify the term. We have this one, psi AB equal to, we already know, substitute that value, we get MBA equation. Make sense? So we have one equation, two equation, and now what we have that here we have BC. For member BC, there is no support or settlement, so that's why psi for BC, but there is no settlement happen because of the horizontal force, right? So there is no psi AB, right? So that one is 0. So again, wrote the equation, theta, we started from BC, so 2 theta B plus theta C and 3 psi BC, FEM 0, so don't need to write. And now that psi BC also 0, we just get to know that things, remove that part. Again, just simplified all the things after plugging the all values, because that one we are saying KBC and we know KBC equal to 2K. We wrote that things before, and then we get another equation for MBC. And after that, we need to write another moment equation, start from MCB, right? So write the another equation MCB, same way, 2 theta C plus theta B, 3 psi BC, and there is no fixed end moment. And we know 3 psi BC is equal to 0. Just remove that one, we have this. And initially we consider that one in another constant value, substitute that things. We just simplified our equation, we get MCB. Okay, now we have another bar. So if you have how many bars? If you have 3 bars, then it will be 6 equation. So MCD, write the equation based on the general equation we have for moment. Again, there is a psi CD we already know, and there is no fixed end moment, 0. And again, look at this one. that we have D is fixed support. That means that theta D equal to 0. So theta D equal to 0, here I wrote, and then this term going to 0, we have only this 2. And this one constant we consider equal to KCD, and KCD equal to K. Go back and check the way I showed. Now I have CD, moment for CD. And now another moment you need to write at DC. Okay, write 2 theta D plus theta C minus 3 psi CD. And now again this term is 0, so I have theta C minus 3 psi CD. This one is constant. Okay, replace that one with KCD. It's a K. We assume that things before, and now simplify the equation, and we have MCD. We have 4 equation. One, this one, another one, this one, then this one, MCB, then MBC, and MBA, MAB. Okay, makes sense? And then after that, what we have, we just solve it. I didn't show all the steps, all other steps, because it's so easy. If you have 4 equation, you can solve it so quickly, and you will get MAB, BC, CD, BA, CB, and CD, all the values. Make sense? I hope it makes sense, because it's so easy math I have ever seen in my life. And then what you have to do, you need to draw shear force and moment diagram. So we have, let me draw it. Hopefully I'm able to draw it. Okay. So we have this one, this one, and this is a little tough to draw it. Okay. So here it's it's a pin support, okay? And not sorry, not pin support, it's a fixed support. I have to draw fixed support. Fixed support here at D. Oops. And then here we have fixed support A. And then this one is B. This one is C. And we have 6 skip here from before, 6 skip, keep 6 skip here. We just compute we just compute, right? We just get from here MAB 26.45. So let's write 26.45. This is 0.45. Okay, keep it. Let me write. This one is keep. This one is fit. Okay. And then here we also get this one. This one is 18.7 keep it. You can separate the structure and show that things, whatever you prefer, it's fine. So we have 26.45 keep here, then this one here, we have these things here, and if we separate it, then we need to show all the steps. Okay, here A, B. So remember that for AB bar, we already compute that things. For here we get negative 21.58 keep fit. Anti-clockwise, right? Keep fit. So just draw the moment diagram. If I'm not saying that draw the shear force diagram, but shear or moment diagram, but still you need to draw that things. You can skip shear diagram if it is not written. If it's specifically written shear diagram, then you need to draw. If there is not written that shear or moment, but still you have to draw free body diagram and draw the moment diagram. And then what we have, that moment diagram 26 downward, then it will be like this, and then this one. So here it's 26 minus this one. So there will be something, that one exactly 21.84. Okay, so this is mistakes. 84. 21.84. So here you will get 21.84. If you draw shear force diagram, you will get that things, but here for this math, we don't need to, because we already get all the moment for all the bar. So we have 21.84 here. That one is negative, so go down 0. Now, if we have 21 negative for this one, so for BC part, what will be happen? 21.84 keep will be positive upward. So it will be like this, 21 up, 8, 4. Oh my God. I just 21, 4, 8 keep upward and then go down. And okay, let's draw 18.7 and keep here DC, CD minus 16. That look at this, AMCB is 16.78 keep. So it's going down 16.7, 16.78 you will get, and you have another one, positive, negative. This one is negative and it's a positive you have. Look at this. Okay. Now moment diagram for this one. Moment diagram for this one. Yeah, this 18 keep downward because it's negative, right? DC negative 18.7, 18.7 keep downward. 18.7 keep downward. Then for this one, 16 points CD, 16.76, keep upward. Oh, 16.76, keep upward. So this one, I think I also, it will be 7.6. So, so here it's not 8, it's 7. 16.76, keep upward. It goes and then go down, minus, right? Then it will be go 0. Make sense? So in that way, if you have frame and you just compute the moment for all the bird that, look at this one, MAB, BA, MBC, CB. So here it's 6. It's not 8. Then in CD, DC. Now you just you have frame, just draw the moment diagram. Don't need to draw shear force diagram because I have already everything, and that using those values, I can draw the moment diagram. Okay. So that's the end for today's class and the chapter 10. In the next class, we are going to read for the exam 2. Hope for the best. Okay. Bye. See you in the next class.